Today, we will have our regular R&D talk. Let me remind you that it's basically our online meetup for research enthusiasts who would like to dive deeper into the deep technologies and see how they are adopted within the industry. And of course, have insights from the R&D experts who then share. Topic of today's conversation will be GenAI 3D or 3D GenAI is the questions I will need to answer, while our speakers will share this pathway for early adopters. So 2D images is already seems to be kind of reality in AI generation, but 3D is still emerging and getting more and more attention. And over the past year, the team have conducted in-depth research in this direction, and we'll share the outcomes today. Basically, what tools are available in the market and what is the quality of generation right now, what to expect for engineers like us and creative professionals from the industry, and what is the readiness of this tool for certain business use case, some of which were already implemented for the customers. So let me basically introduce our today's speakers. Sam Frish, he is R&D practice lead with more than 10 years experience in game development, virtual and augmented reality. He started this direction a long time ago within the SoftServe, and now is leading interactive practice with the main focus of 3D generation research as for now. The second speaker is Igor Romanovich, who is male R&D engineer from R&D Interactive team. He has more than 5 years experience in the industry and was involved in creating such amazing solutions as fortune teller from one perspective to a warehouse sim demo from another one. So basically, guys, the stage is yours, and everyone, please, if you have any questions throughout the session, feel free to ask them either by raising your hand or putting the comment into the chat in Zoom or in Workplace, and we'll answer them in the end. So, Sam, Igor?
Please.
Yes, let's start with our agenda, Sam.
Our agenda is straightforward. We will talk about what is GenAI 3D. We already know that it's GenAI 3D, not GenAI, and where is it applied. We tell about Gary Houdini and some focuses. And it's going to be pretty much of technical details. And the largest part, I believe, is the way to go, because the topic is living in the future, and we are inviting you to the discussion. And let's go.
Yeah, so thank you, Bogdan, for the introduction. We are Igor Romanovich and Sam Frish from the interactive team. And Sam, please, straight to the business.
I'll tell you what is GenAI, basically based on our research. So we delved into this topic like more than a year ago. And firstly, it's definitely some structurizing of available information. And Igor, please show me the slide. So what we can structure in topics generative AI from different levels. So at the high level, we can do pretty straightforward things. We can generate text and put this text into 3D scenes or objects. We can take 2D images and make 3D objects from those images. And we can transform videos into 3D content. If you go a bit lower, we have techniques, technologies, algorithms like MVS, multi-view stereo, SFM, structure from motion, nerve, neural radiance field, or latest fancy Gaussian splitting. Also, if you look at the same level, but a bit from a different angle, we have different types of geometry. It could be point clouds, naturally from points. It could be voxel grids from volumes, cubes or something like that. It could be radiance fields. It's a piece of volume put on the array starting from this starting point, like radian. And the most common are meshes and textures. We can have vast of formats to present 3D data. ChatGPT recently suggested me that Omniverse could handle 25 of them and tried to deceive me because it's not like that. And anyways, most cases we are working with FBX, USD, or GLTF. Here is GLTF binary. And the last differentiation point is, are we using some machine learning, or are we using old school bulletproof traditional algorithm?
So where is it applied? Basically everywhere. In virtual production for the scene, movie making, synthetic data, especially for automotive, for e-commerce, for generating warehouses for the e-commerce, for the avatars creation, for real estate virtual tours, and for the game development. Two areas that we highlighted for us is automotive and this abstract virtual worlds creation, because for us they are like most popular from the customers. And Sam, getting back to you.
Our favorite Gary Goodinian focuses. Naturally, we do a lot of focuses, and in this for research, it was more than 50 pre-sales in more than 1 year or half a year mostly, and 18 of them were directly connected in this focus area. And we have 4 clusters. The largest is a virtual workstation. We have virtual teacher in 3D and virtual assistant in 3D, mostly for healthcare and finance. And we have 3D object generation, which applies pretty everywhere. And in more focused depths, avatar for kids have grown from just avatar. The things for kids are usually more complicated. They are with trunks, tails, fury, and so on. So we had previously just an avatars, and now we grown this up to avatars for kids. And vice versa with virtual world creation, we had a demo, small demo, which creating GPU servers in Omniverse with ChatGPT or similar LLM. And it's grown up from the publication of NVIDIA at SIGGRAPH. It was 7 minutes video, and it's taken us several months to recreate. Then it's grown up to large demo of warehouse, where this kind of conversational interface is utilized. And the world is created based on that, and it was presented at GTC conference. GTC is for NVIDIA GPU developers conference. So it's large and successful.
Great. So let's jump to the technical details regarding these demos. And let's start with the first one, with the avatar for kids. So we got this pretty fancy avatar with 9 significant features. At first, our avatar is running on the edge with no RTX GPU required. We have non-humanoid character support. We have multi-language support. Also, we achieved real-time acceptable latency. We have only one GPU cloud instance per session. We have large language models, retrieval, augmented generation, and fine-tuning capabilities for company-specific content. We have guardrails support for safe usage for kids. We have on-the-edge lip sync, and we have iOS Android support. Let's talk this in more details. So the first one is TTS, text-to-speech. We've performed custom voice retraining, which is pretty good, but it will be better with more data. Initially, we trained it on 3 hours of generated voice. It's good enough. Training took 8 hours on a single GPU on RTX 3090. TTS latency is 2 times faster than one of the industry-leading solutions. Ours 1.8 to 2.6 seconds versus 5+ seconds on simple sentences. And we compared it with previous demo, which took 10+ seconds on mid-length sentences, and our solution performed more than 18 times faster. Going back to lip sync, we have tried audio to face and Oculus VR lip sync. Audio to face from NVIDIA is good, but it is rather expensive to run. So we have explored the Oculus VR lip sync, and it showed promising results. It runs on the edge with no additional costs from the cloud side in counterbalanced audio to face, but it's a bit less robust than audio to face. Regarding the large language model part, we have estimated latency for compatible retrieval augmented generation models such as Claude 2 and Titan. They were slower in comparison to quantized models based on open source Mixtral and Mixture of Experts. Also, we have experimented with a brand new JSLM, also known as Joint Speech Language Model, called Gazelle. It's very fast but inaccurate model, but it has around 200 milliseconds latency and built-in Meta's voice ASR. Also, we have experimented with fine-tuning large language models with client data. Depending on the amount of data, it takes from 3 to 9 hours on a single GPU with quantization enabled. But it's shown bad results with many hallucinations. That's why we're going with RAG, retrieval augmented generation, which is more robust options from our perspective, and it requires no fine-tuning or training. Also, we've discovered that Mixtral and Mixture of Experts are more accurate with data in RAG. And for speed sakes, we applied quantization down to 4 bits for each model, and the model's accuracy is still pretty good. Also, we have experimented with open source LLM guardrails. Unfortunately, regular expressions does not apply directly to joint speech language models voice input, but we also took a look at the guardrails on Bedrock, which are still in beta or preview for over a year. And Sam, please talk about the benefits and limitations.
Pretty much of technology usually run to complications and limitations, but we managed to make all the benefits or all the possible the time benefits of it. First of all, we started from operational cost cuts because the technology is hungry itself, and when we can edit several hungry points and become not acceptable. So we find out the way to run our solutions, models, and so on GPU cloud, which is specialized for GPUs, and it has 2 generation forward GPUs there. In addition, the costs are 2 times less than on usual hyperscaler. We found out that RTX workstation instance at AWS is usually needed to run this NVIDIA stack-based low-powered avatars properly. It's expensive, but it's providing all the possibilities. One funny but important detail that we can't use microphone with remote desktop connections without the license from the Microsoft. So we have to find out how to do it, and then to acquire the more license for microphone in 120 days. We found the way how to provide this 3D, this generated in 3D avatars and so on to user handheld device without GPU. So we have GPU on the backend, and we have ordinary MacBooks, iPhones, iPads, or Androids. With running we upload pretty everything on the edge, but we have this running on the edge as an application, and we have here the boost in latency if we're comparing to just ordinary streaming of video and audio. Once again, about GSLM, this combined approach seems naturally that one thing is going to work faster than 2 things combined, at least when we are talking about services connected via some web or something like that. So ASR, audio speech recognition, and LLM, large language models, all together working good, providing best results, suitable, so on and so forth. But experimental things like Gazelle, GSLM, joint speech language model, provides speed in like Igor said, 0.2 seconds, maybe 0.5 seconds. But with combinations of different models, usually latency is up to 1.5 or 2 seconds.
And let's dive into other field of interest of us. It's virtual world creation. So we have tried 3D object generation and 3D scene generation. So for example, you can get 3D models via text to 3D. On the left, you can see this example. We asked for the GPU server. And then you can take them and stack together to combine them with the assets from the library. We took this asset from NVIDIA Deep Search library. And as you can see, they are perfectly fitting inside the shelf. And yeah, also we have experimented with both 3D scanned and GenAI 3D generated objects in Omniverse. On the left, you can see these GPU servers that we generated and PCB that was actually scanned on 3D scanner. And on the right, you can see the box from this PCB. It is also scanned on the 3D scanner. And they're pretty good results. Also, we have experimented with GenAI 3D for the digital twins. On the video, you can see our proof of concept that utilizes our GenAI 3D for the virtual infrastructure. So the scene is generated with OpenAI ChatGPT and then with a mixture of experts by Mistral AI in NVIDIA Omniverse. And basically we asked the system to generate us 32 NVIDIA GPUs, and as you see, it generated us 32 GPU servers. I could say in a blink of an eye. And Sam, please tell regarding this 2D to 3D.
Yes, thank you. Let me jump in here. Servers powerful and complicated, but when we come into some organic objects and furthermore for some interpretation of organic objects, specialization for fits, we have maybe several orders of magnitude more complex tasks. So we try to experiment with this complex stuff. We experimented with 7 generative AI technologies on the market, more or less in comparison and benchmarking. But actually, it was more than 20 different technologies from different vendors, open source, and so on. First group is Luma, Meshi, and Pseudo AI. They are traditional text to 3D or image to 3D. We kind of replacing creative people here with technicians and AI tools, which is not very good in my mind. And that's why KDIM 3D here is another type of tools. It's a tool that augment in artist teams. You have artist teams who create in the models and AI enhancing their work and speed it, allowing them to speed up their work. And this way for me is the best, at least from ethical perspective. The third, not in the group, but outstanding, is the nuclear deep search from NVIDIA. They are aiming the enterprise segment, and they are doing this on very mature level. So if you are willing to generate mature world for some manufacturing or robotic and so on and so forth, so tools from NVIDIA are the best fit here. We prepared outcomes of this benchmarking and everything about that, accuracy parameters on our suggestion in point of view article, and it's linked. I believe it will going to be a follow-up and you can read it. And this is our contribution to SoftServe offering in GenAI. Furthermore, when you try to do something like that, you say GenAI, you get ChatGPT. You said say GenAI 3D, you get something like, oh, you're creating the new Blender. But when you're starting to experiment to put the things together, you can find out use cases for creative industries. When you do some kind of specialized work, maybe Igor will try to do it back and forth and make them dance and spin. Yes, thank you. So here we have dancing astronauts, and they done with 2 options. One is Luma AI and Mixamo, and the second is Nicely and Animate Anything. One is literally 1 click, other 1 click plus region with highlighting joint points on the skeleton. And on the bottom, we have a dragon. This dragon is living on Pandora, and the dragon was created by professional artists in the brush, and AI has textured it with a text prompt Please texture me as a dragon from Pandora, and looks like it could live in Pandora with such colors. This is more info still in this POV article. Like it comes up to validate the article, the hypothesis with the market to contribute more into GenAI offering and to build partnership with the leaders in the market in this direction. And the last but not least in this section, the most challenging part, when you creating text to 3D and you have to create something ordinary like a cup or something symmetrical, it's already robust working. But we don't look for easy ways. And when you have tails, plush, trunks, flight ears, furrows, and either, it's still a good challenge for GenAI models. Here we have a review of an experiment of state-of-the-art algorithms with zero-shot learning. Here we represent 0, 1, 2, 3 plus plus, and the 0, 2, 3, 4, 5. And you see the risk is pretty much room for improvement. We have several ideas actually how to contribute there. And the way to go, it's long and challenging, like we love to. We put our avatars as an AP initiative. So we experimented with this toys for kids, and we find out how to use this childish, cartoonish voices. We find how to run it on the edge to bring it to curious noses and hands of young ladies and gentlemen. We delivered the POC. My daughters, Sarah and Rebecca, were fascinated with this demo. They were asking the LLM surprising questions, and they managed to find the question where LLM told me, sorry, I don't know. But actually the questions were like, why dinosaurs have extinct, or why is how the solar system works. I believe it's pretty good for replication and to bring this for all the kids in the world, or at least bring ability to more of them. We can use GenAI and GenAI 3D to enhance audio-visual educational process for children, and I believe for not children too. For grown-ups, I mean, the existing education can be replicated to physical toys world, and the good idea is to bring your one toy in the physical world and make it live in digital on phone or tablet. You can get value of there with boosting real toy sales and putting up the traffic on your website or up pages used educational technology or something like that. And definitely you can make premium service to teach the kids like that.
And also on this slide, we have represented how we made qualitative improvements in time. So in January, we had AWS instance, mostly NVIDIA technology stack, RTX enabled user device as requirement. And now in June, we could use any cloud instance. We are using mostly open source technology, and the device could be any, especially edge devices like Android or iOS phones. And also, while doing improvements, we've improved cloud consumptions. As you can see on the right, we have estimated the consumption of GPU resources on the cloud to be 5,000 sessions per day. And we have achieved 6 times lower costs with different system optimization, use of various tech stack, and ability to use cheaper cloud provider. And going to the second IP initiative. So we have this system in mind. GenAI 3D platform as a service. So basically the system to generate 3D scenes using text prompt or maybe voice prompt. We have already developed 2 demos, one of which is used as a benchmark for the research report in the blog. And we aim to create MVP and IP based on it. The business value of this thing is like for the AAA scale project, we could significantly speed up the development process and cut a lot of costs. For now, we have 1 client for it and dozens of prospects. And yeah, as I mentioned earlier, we have used our research report as a part of joint promotional publication with NVIDIA and NextGen. And now to QA session. If you have any questions, please.
Yeah, so Igor, Sam, thank you for very basically, I would say, at the same time, concise and clear presentation about 3D AI, and it's always cool to see how basically comprehensive approach for technology can help make some 3D Gen AI use cases that were earlier overall like impossible, unimaginable. Who can imagine you can run some complex, right, Gen AI system on your mobile phone, for example, so as avatar. So that's basically, I would say, really amazing. And maybe someone from participants has any questions to Sam or Igor. So let's wait another few minutes because I know that it takes time to formulate it. Feel free to ask either in the chat or in the workplace. Meanwhile, maybe from my perspective, there is one question. The question is the following. Where do you see the next big thing within 3D Gen AI? So what do you think will be the use case that isn't yet achievable because of the technology readiness, but can become reality, for example, next year or the following years?
Let me pick this one. I taken this from marketing materials of one of the leaders of this technology in the market. On the left, it was fancy papers, tech demos, and fantastic results. And the other were needs of business with complicated platforms, with tools for major business and so on. So for me, the next big thing here is to cross in this chasm on the Roger curve to make this technology mature. And it's here it's all as usual for AI, it's data, it's GPUs, and it's community who is working on that. I believe it's going to be like with text or with images. So next breakthrough is a mass adoption.
Okay, so basically democratizing technology. You are like Jensen, right? So that's a really good way to go. Thanks for the answer, Sam. Igor, maybe you have something to add, or I can move to the next question.
I mostly agree with Sam that the next step is to cross this chasm, and yeah, but you know, there's a lot of room for improvement anytime, and maybe there will be some significant breakthrough, for example, in text to animation, which would be super great for the 3D artists.
Great. Meanwhile, we have a few more questions. Mariusz Bienek, hope I pronounced the surname right, had a question. What about potential copyrights violation? It's a big thing currently in music industry. What about IP for 3D creation from 2D images? So what do you think?
Let me take this one. Maybe Sam will add something after. So these proposed models, for example, 0, 1, 2, 3, are trained on the specific data sets. In this case, it's called Observers, I believe. Yeah, it's called Observers, and it is pretty aware of these copyright issues with the authors and other things. So it basically has the filter for the models that are not allowed to be used in AI training, and it has other filter which shows on only models which are allowed to be used in this AI training. And a lot of 3D platforms like SketchUp, Free 3D, and others, they're currently working on mechanisms to allow you to make this tick box is not allowed or just allowed for usage for AI training. So I believe it's pretty much solving this issue with copyright claims. But Sam, maybe you can have something to add.
You covered mostly things like that. I want to tell that all, but maybe most of all providers of 3D content on the web has updated their copyrights recently to overcome this boom and help us to close this chart. And furthermore, the projects like Observers already found a way how to filter everything available on the web. And so far in the open sources with proper licenses is up to 10 million models.
Thanks for your answers. And basically, maybe short thing around that. So maybe for there are also certain models like NVIDIA. This one in collaboration with Shutterstock, like NVIDIA ID5, where they just use copyright protected data of 2D images in order to train the model. So it's also a way to go. The companies like Adobe, Shutterstock has this approach as well in order to tackle this issue, and they're kind of copyright advantage. One more question from Christian Chaba. The question is, how does this work better from any hyperhuman Dorin, or as far as I understand, any other tools, for example, for avatar generation or something like that? So the question is the following. Probably it refers to the avatar.
The answer is we have here temporary advantage of using technologies altogether. Our avatars here is working on the edge devices without GPU on the edge, but utilizing GPU on the cloud. So it's we are not like NVIDIA who can do everything with everything. We find our small niche and we build the advantage with this niche. Most likely it's temporary, but still it's good time to, and it's titled for early adopters.
Got it. Thanks for answer, Sam. So, Igor, do you have something to add?
I believe no, Sam covered pretty much of it.
Good. So Seems there are no questions as for now, neither in the Zoom or workplace, but still, if you have them, feel free to reach out Igor and Sam directly and ask those specific questions, or just drop the email for R&D.com, where both of them are in the copy of recipients. So thank you everyone who joined. Sam, Igor, thank you for amazing presentation, and see you next time.